Okay, so the radian measurements you probably already have. You probably already have the triangles, and we still can't find the sine of 15 degrees. Okay, without a calculator. This is what? You do that a lot.
Stop one foot.
Now these are opposite angle identities. The cosine of theta and the cosine of negative theta, because of all students take calculus, this angle and this angle, all the way around, is going to give you the same values. Because the cosine is positive in quadrant 1, it's also positive in quadrant 4. So cosine of theta and cosine of negative theta are going to be equal. Same thing with quadrants 2 and 3 for cosine. So if your theta was a quadrant 2 angle, negative theta would be a quadrant 3 angle. They would still be the same value. Whereas sine in quadrant 1 and quadrant 4, the sine for theta, where is it? Theta down here, and sine of negative theta, they're going to be opposites. The sine in quadrant 1 and 4 and the sine in quadrants 2 and 3 are opposites, not equal. How's that taste? Okay, again, this is an old identity. We've done it before. Nothing new. We're going to look at some identities today for sums and differences of angles. And what I've done is I've taken a unit circle. How do you know this is a unit circle? Correct. So at this point right here, it's identified as 1, 0. So with those coordinates, you got to be looking at the unit circle. I picked two random points. I called this point over here on the left A, and coordinates would be cos alpha, sine alpha. And then B up here, the coordinates are going to be cos beta, sine beta. And beta is this angle right here, the blue angle. This is beta. Alpha, the green angle right here, this is alpha. Goes to this one right here. The red angle in between these two rays is the angle alpha minus beta. In the dotted green line would be the distance from A to B. So these formulas, I'm going to derive the first one for you using law, sines, and distance formula. The bottom line is these formulas you really need to come away and memorize them tonight. Because tomorrow we're going to give you another pot. So you want to make sure that you have these formulas pretty well memorized tonight. The triangle we're going to be utilizing for the derivation is this triangle right here. And with the origin, with A, and with B. And I'll separate that triangle out for you. So when you look at this picture, we're going to take this picture and we're going to find the distance from A to B. And the first way we're going to do it is to use the distance formula. So we're just finding the distance from A to B. You might remember the distance formula. The difference between the x's squared plus the difference between the y's squared. And then the square root of that sum. So your x's are cos alpha and cos beta, and your y's are sine alpha and sine beta. So when we derive this, we're plugging in for the x's cos beta minus cos alpha, and for the y's we're doing sine beta minus sine alpha. The order is not really that critical. Whether you do alpha or beta first doesn't really matter. In Algebra 1, when we give formulas, like quadratic formula you get in Algebra 1, I just say, look, here, trust me, it works. In Algebra 2, when you do the quadratic formula, we derive it. Here's where it comes from. So in honors, we want you to be able to see the derivation, not so much that I'm going to say on the test, derive this, It's just that you could if you had to. You can think through the process if you have to. Those of you who are going to go into calculus, those of you who are going to go into college and be in a math science field, it's not that you know the derivation of these formulas today. It's just that you can follow the derivation. You can think through the derivation. Almost everybody now in the two honors classes can square binomials. I still have a couple of people who give me cos squared beta minus cos squared alpha is their final answer. But almost everybody at this stage can square the binomial. Square the first, cos squared beta, twice the product, 2 cos beta cos alpha, square the loss, cos squared alpha. Repeat with the signs. Now in yellow, you have a cos squared beta and a sine squared beta. What's that give you? 1. And in green, cos squared alpha plus sine squared alpha. How much is that? It's something like 1, yes. So in yellow you get a 1, in green you get a 1. That's the Pythagorean identity. Sine squared plus cos squared, or cos squared plus sine squared is equal to 1, as long as you're using the same angle. And 1 plus 1 is 2, and I squared both sides. So here's an AB right here. If you square both sides to get rid of the radical, you have AB squared. And it does. You may not understand why I'm squaring it. It doesn't really matter right now. You'll see that in a minute. I'll connect these dots. Give me about 5 minutes. We'll have this all connected. So the distance from A to B is square root of 2 minus 2 cos beta cos alpha minus 2 sine beta sine alpha. And if you square that distance, you get it distance squared and no radical on the right. Everybody with me on that? So this is the distance from A to B, the green dotted line right here in the picture. So if we do the same thing, same picture, and we pull out that triangle that's centered at C here, so this is the center of the circle, then the triangle has an angle right here of alpha minus beta, the red angle. The radii of the circle are both 1, so that means CB and CA are both 1s. And we're trying to find the distance from A to B using law of cosines. So you may remember law of cosines. And again, I'm doing it without the square root. So AB squared is going to equal side squared plus side squared minus 2 side cosine of the angle in between, which is alpha minus beta. And if you clean it up a little bit, you get 2 minus 2 cos alpha minus beta. Law of cosine is a lot easier than doing distance form. What's this say? I know you can't read it. It's upside down for you. There you go. Formal education will make you a living. Oh, self-education will make you a fortune. Then he has a picture of a guy stealing a diamond.
It's not the same thing. I get it.
Oh. I think that was implied. That's what I said. If I thought it. It didn't come out loud. Unlike Caitlin, there's some sensors that prevent everything from coming out. Really? The one that died? Oh no, that's Bambi lived. It was Bambi's mom that died.
Thank you.
Yeah. Well, think about Bambi.
You brought it up.
You did. Are we good on this? So now let's connect these two together. So the first time we found out that AB squared was equal to this mess, using distance formulas. And then we found out that AB squared, the distance squared, was 2 minus 2 cos alpha minus beta, using law of cosines. What has to be true here?
Equal to each other.
Yeah, these two, the blue and the red, would have to be equal. So 2 minus 2 cos beta cos alpha minus 2 sine beta sine alpha is equal to 2 minus 2 cos alpha minus beta. And that looks just like a big mess. And it is. Notice that there's a 2 on each side. If you subtract the 2, and then if you divide everybody by 2, you'll end up with cos beta cos alpha plus sine beta sine alpha is equal to the cosine of alpha minus beta. And if we switch that around, cos alpha minus beta, that means the cosine of the difference between two angles, will equal cos alpha cos beta plus sine alpha sine beta. And that is the cosine of a difference formula. On your identity sheet, it has sum and difference formulas right here. So this is the first difference formula, the cosine of a difference. Relax, relax. It was less than a second. You guys go right into panic mode. You're the people beeping at me when the light turns green and my foot's in the air from the brake to the gas. Do you drive? Okay, when you're driving, you'll know what I'm talking about. So, the light turns green, your foot was where?
Oh, okay, I got it.
Okay. Hopefully not.
I got it. So.
Regardless, you have a foot on the brake. And if you have a manual, you have one foot on the clutch, one on the brake. Don't what if, man. Even if you're on the clutch, you should have a foot on the brake. Yeah. I had a manual transmission until last year. Love it. Me too. It's because you don't have a manual transmissions are fun. Participate. All right. So if you have the cosine of 15 degrees, how can we utilize? It doesn't matter. It's a formula I just came up with. It was the cosine of a difference. So right now, no, that's not an answer. It's a formula. This is the cosine of the difference of two angles. Cos alpha cos beta plus sine alpha sine beta. We can use that formula to find the exact value of, in this case, the cosine of 15. How can I use that formula to find exact values for the cosine of 15? What two angles would subtract to give you 15? Don't say 20 and 5. 45 and 30, or 60 and 45. Either of those would work great. This example is just using the 60 and 45. Bam. This is the cosine of the difference of two angles, which is cosine cosine plus sine sine. You weren't until 2 minutes ago. So if you know that 60 minus 45 plus you is equal to the angle you're looking for, then cos 60 cos 45 plus sine 60 sine 45 will give you the value of cosine of 15. Cosine of 60 is a half. cosine of 45 root 2 over 2, sine of 60 root 3 over 2, and sine of 45 root 2 over 2. That means that you're going to get root 2 over 4 and root 6 over 4, which gives you root 2 plus root 6 all over 4. Okay, so there's certain angles that you'll be able to find using the cosine of a difference, 15 being one of them. There's others also, but just be aware that you can use this formula. Now, if we go back to this idea right here, and we're working with cosine of alpha, or cosine of theta and sine of theta, notice that the sine of theta and the sine of negative theta are opposites. So if we were to change this from cosine of alpha minus beta, and we made beta be negative beta, okay? You'd have cosine of alpha minus a negative beta. What would that become? Positive beta. Am I going too fast?
No.
So if I have a negative beta in this formula, cosine of negative beta doesn't change. It's the same as cos beta. But what about the sine of negative beta? To the opposite, which would change this to a minus, which means that if we do cosine of alpha minus minus beta, or cosine of alpha plus beta, the only thing that changes is the sign here. So you can write them separately, or you can do them all together with a plus minus and a minus plus sign. Cos, cos, sine, sine, and if you're doing a minus, it's plus. If you're doing a plus, it's a minus. So these two signs are opposites. These two signs are opposites. Right? Why is what reversed? Right here? When you're plus, in the formula it's minus. Right? When you're minus, it's plus. So all I did was combine these two and these two. And they're obviously upside down. So this is the cosine of the difference and the cosine of the sum of two angles. Please learn them tonight. These are the formulas for the sum of the sine of the sum and sine of the difference. So they're very similar, yet very different. So sine of the sum is sine cos plus cos sine, and the sine of the difference is sine cos minus cos sine. And it has to be in the right order. For the sum, the order is not critical. But for the difference, it is critical, so you might as well learn them both the right way. Sine alpha cos beta plus cos alpha sine beta, and then sine alpha cos beta minus cos alpha sine beta. You absolutely want to get those dialed in. Any questions on any of those? you can see the derivation. I'm just saving a little bit of time. The derivation for the signs are in your book. They're on page 370 if you're so inclined. You can check those out. So how do they manifest themselves? How do we utilize them? For example, sine of 15 degrees. So if you're going to do the sine of 15 degrees, what's equal to the sine of 15 degrees? What would you use? Here's 30. And what? 45. So 45 minus 30 is 15 degrees. So that's going to be the sine of 45, cos 30, minus cos 45, sine 30. And again, the order does matter. Not the sine cos part, but you should do it in that order. Sine alpha cos beta, cos alpha sine beta. What is the sine of 45? Root 2 over 2 said with minimal amounts of confidence. How about cos 30? Cos 45. And sine 30. So a lot of you don't know these. And you should, and you need to study them to get yourself dialed in. So when you simplify, it's root 6 over 4 minus root 2 over 4. Root 6 minus root 2 over 4, all over 4. And root 6 minus root 2, Corey, is root 4, right? Root 6 minus root 2 is root 4. Really? 6 minus 2? Right, so we're going to combine them and make it root. Not having it yet. So the sine of 15 degrees is root 6 minus root 2 all over 4, right, Jose?
Yeah. That's what I said.
No, you said over 2.
Minus.
It is minor, and I don't mind correcting your minor errors. I'm getting really good at it. But I charge to do it. Now, how about 285? How about 285? What are you going to do with 285? So the sine of 285, what's the reference angle?
45.
Multiple choice response on this one. 15 degrees.
75.
75, 75.
15 degrees.
Here's 285 right here. How do you get to 285? 360 minus alpha. So alpha has to be 75. So we're going to be looking at the sine of 75 degrees. Then you need to whip a little, all students take calculus on it and realize what? It's negative. So it's the opposite of the sine of 75 that we want to deal with. Now you got to be really careful with this stuff. That negative right there is going to cause some issues. How are we going to deal with 75? Because most of you haven't memorized your values for 75. You can if you memorize 15.
Can you do that this year? 45 minus 30 minus 45. That's like
28, 32, 79, anything.
120 minus 45.
And you memorized 120, did you?
Well, isn't that kind of in the
No cursing.
45 plus 30.
45 plus 30? Yeah, that's the ticket. That's what we want to use. How does the sine of 45 plus 30 work whatever it is, you want to make sure you take the opposite of that. Okay? So we're doing sine of a sum. Sine of 45 cos 30. Plus cos 45 sine 30. Make sure you put it in brackets or parentheses and put a minus in front. Deal with the negative after you've simplified everything. What's the sine of 45? Over 2. How about cos 30? You guys should all have this stuff right here. And if you don't, you need to get it dialed in. Obviously, we haven't done this in a while, and obviously you're rusty because hardly anyone is responding to knowledge level questions. What is the cosine of 30? Root 3 over 2. How about cos 45? And sine 30? A half. Again, don't worry about this negative until you're all simplified. We're not solving. We're doing this. And this is the formula that allows us to solve or evaluate this. So it's not, we don't even care about this. This isn't going to be our answer. So when we simplify, we're going to get root 6. We're going to distribute a negative. We have negative root 6 over 4 minus root 2 over 2. And we don't want the opposite of the sine of 45 plus 30. We want the sine of, sorry. That's right, as Jose would say, it's inconsequential. What are we really finding the sine of? 385. So that's the answer we're looking for right here. And that's the way your work needs to look. And those of you who think that details are inconsequential, think again. Any questions on what we did so far? Try this one on your own. I'm giving you the formula. Oh yeah, we can do it if you want. Yeah, we can do it. Yep. Okay, so now I'm going to kind of go through and show you the other kind of questions you're going to see. So now they're going to play Jeopardy. They're going to go the other way. And they want to know what was the question. So if this is the work, which formula are we using? We have cos minus sine. That's the cosine of the sum. So you need to know this blue formula. And you need to know that if I have cos minus sine, then that must have been the cosine of alpha plus beta. I know. Which is the cosine of, which is half. So this mess right here simplifies to a half. It's just annoying. Learn the formulas and you'll think 3 points. Well, you don't have to do any work. They've done, if you know this just by looking at it, they, oh, I'm not having this conversation.
You have to look at the formula, write it to the right of, or you just put.
This is the question.
I'm in the blue part of the right side, you have the right side.
No, I put that there so you would know that that's the formula.
What is that?
Hula hoop?
No, the little crossing.
Well, when you put another set of crosses this way, it's space. Right now, it's just a coordinate plane.
What's it giving me?
This is the x-axis, this is the y-axis. You might have heard of those before.
I got that.
The z-axis goes this way.
So why do you have it?
Because I teach algebra 2, and we do three-dimensional graphing, and we talk about solving systems in 3 variables, x, y, and z. I'll get right on it. You most certainly did do x, y, z systems. All right, so for this problem, now you see that we're sine, cos, sine. So we're doing the sine of a sum. So it's the sine of 5 pi over 12 plus pi over 12. Whoa, 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 whoa. When you add these, what do you get? Right here, folks. Hang on, hang on. Ladies, gentlemen. Yeah, put a sock in it. When you add these, 6 pi over 12. So what is the sine of pi over 2? Again, how old are you? Not how much you weigh. You're answering his correct. His question. His answer was correct, just not for the question I'm asking. Yes, you did. These problems are not difficult if you know the formulas and draw the pictures. Gentlemen, what they're doing now is they're telling you what sine of alpha is and what the sine of beta is. However, they are also telling you a restriction for alpha and a restriction for beta. And it is a quadrant restriction. So this quadrant restriction for alpha tells you where are you? First quadrant. So what you want to do is you want to draw the picture. Now some of you are going to say, oh, I'm not drawing a picture. I don't need to do that. This is alpha right here. If the sine of alpha is 4 over 5, what do I put in my picture? The opposite is 4. Hypotenuse is 5. And the adjacent has to be 3. Okay, Pythagorean theorem. Now we do the same thing for beta. Where do we have to draw the picture for beta? Quadrant 2. So it's going to look like this. And this is beta here. We know that the sine of beta is 5 over 13. What's this? 24, 32, 7.
And the answer is
Congratulations, not 12. Here we go again.
Yeah, I think it's 12.
If it was 12, this was what I would sit here and I'd say, yes, it's 12. What was that? Negative 12. That is one of the issues for this problem. So if we're going to do cos alpha plus beta, you got to know your formula. Again, cos alpha plus beta is cos minus sine. And as Sean said, they're very similar, but they're not exact. So cos alpha plus beta is cos alpha, cos beta, minus sine alpha, sine beta. In tonight's homework, if you write out the formulas every time, you'll probably have them memorized by the end of the assignment. It's not going to take you 2 hours. What is the cosine of alpha? 3/5. What's the cosine of beta? -12/13 minus sine of alpha 4/5 sine beta 5/13. So you have enough information so that you can get -36/65 minus 20/65. Did I make a mistake? Equals -56/65 for cosine of alpha plus beta. Mostly arithmetic, if you know your formula.
That's the answer.
Nice harmony on that, and yes it is. Yes, sir? Didn't ask for the angles. If you wanted to know the angles, you'd go sine inverse of 4/5 and sine inverse of 5/13 and just make sure you get to the right quadrant. They're not asking. All right, so there's a lot of formulas to deal with. Sine, sum and difference, cos, sum and difference is 4. You need to know those 9 values, exact values in quadrant 1, plus your quadrantals. When it says show, if you remember, it's the same as kind of a prove. You want to leave this side or this side alone. Which one are we going to mess with here?
Right, left side.
Yeah, leave the right side alone, and we're going to start with the sine of 3π/2 minus x. All right? And according to this formula, the sine of the difference of two angles is going to be the sine of 3π/2 cos x minus cos 3π/2 sine x. What's the sine of 3π/2? So we're going to have -1 times cos x. What's the cosine of 3π/2? So 0 times sine x is going to be gone. You're going to have negative cos x is equal to negative cos x. That's what you were trying to prove. That's it. Remember, leave one side alone and mess with the other side. Done with this problem? No. I can stop. You want to stop? I'm good. Good Lord. Okay, if I can get you to give me your attention to finish this. If it's secant, it becomes 1 over cos pi over 2 minus x. Okay? When you have the cosine of a difference, that's 1 over, if you don't remember cosine of a difference, we probably have it up here somewhere. Here's sum. There's cosine of a difference. So cosine of a difference is cos plus sine. The signs are different, but it's cos. What is the cosine of pi over 2? 0. What is the sine of pi over 2? So that's going to give you 1 over the sine of x. What's 1 over the sine of x? So you're proving that this is equal to this. Question, Sean, or just?
That needs to be called.
Yes, sir. We watch the bulletin every time they give us the bulletin. They're not making them. I'm not the bulletin teacher. I'm just the math teacher.